Alrighty guys, so today we're going to be talking about similar polygons. Before we get started, I'm going to draw my screen, oops. Before we get started, I wanted to bring up a little difference between congruent and similar images. So previously we've talked about congruency, and that's when you have, say, a triangle, two triangles, that have the same angle measurements and the same sides. Okay, so both the angles and the sides are congruent or the same. The main difference with that is if we're looking at similar polygons or similar shapes, where congruency has congruent angles and sides, similar polygons are going to have angles that are congruent, but their side lengths are proportional. Okay, this is very important, proportional side lengths. Okay, so what this might look like. We have ABCD, we're told, is similar to WXYZ. Another thing, similar to can be expressed as this little squiggle right here. So you could see it written as ABCD squiggle WXYZ. So in these shapes, we know that if they are similar, the corresponding angles, so A and W, B and X, C and Y, they're going to be congruent. Okay, so from one angle to the other, congruent measurements, same thing. The difference is the corresponding sides. So AB corresponds with WX. We know that by our statement. Okay, it says that right there. AB over WX would be how you set up your corresponding sides. Okay, so AB over WX, BC over XY. If you guys notice, we have 15 over 5, 12 over 4, 21 over 7. So these corresponding sides all have the same proportion of 3 over 1, right? So the similarity is 3 over 1 for the side lengths. Okay, so what that looks like if we're going to try it on our own. Okay, so we have triangle FGH is similar to triangle JKL. We want to list all the pairs of congruent angles and write a proportion that relates to the corresponding sides. Okay, so we have two things that we need to do. List the congruent angles and write a proportion. Okay, so first we want to just use our similarity statement. That is going to be right here, where it says triangle FGH is similar to triangle JKL. This makes everything easier as far as pairing up what goes together. So triangle JKL. Okay, so step 1, finding our corresponding congruent angles. We're going to say that angle F corresponds with angle J and is congruent. Angle G is congruent to angle K, and angle H is congruent to angle L. Okay, and I'm just pulling that straight from my similarity statement. Okay, second step, we want to write a proportion. Okay, so we need to compare our sides between the two triangles, right? So we know that side FJ, or FG, my bad, corresponds with JK. Okay, side GH corresponds with KL, and side HF corresponds with side LJ. Each of these sides, if the similarity statement is true, will be proportional. Okay? So, one more thing, we have the ratio of the lengths of the corresponding sides of your two similar polygons is called the scale factor. So what the scale factor does, it just says from this image to this image changes by this much. Okay, so scale factor we could say is, oh my goodness, there we go. Okay. Scale factor is how much changes between shapes. Okay, so if we're told the diagram ABC, this one here, is similar to XYZ, we know that AB corresponds to XY. Okay, so AB is 6, XY is 3. We want to figure out the scale factor from ABC to XYZ. So we're going to look at our scale factor from big triangle to small triangle. So the big triangle is 6, it goes on top. The small triangle is 3, which goes on the bottom. So our scale factor would be 2. Okay? Next, if we're going from XYZ to ABC, we're going from small to big. Okay? We start with our small side length, 3, that goes on top of our ratio. And we end with our side length of 6. Okay, this would make our scale factor 1/2, which means that triangle XYZ is half the size of ABC. Okay? Now what this looks like in an example, like a real life example. So here, photo editing, it is very important for resolutions and photo sizes to be proportional so that you don't skew your images, okay? So in this example, Kuma wants to use the rectangular photo shown here as the background for her computer's desktop, but she needs to resize it. Determine whether the follow rectangular images, either the blue or the green, are similar to the red, okay? If so, write a similarity statement and the scale factor. Explain your reasoning. So we're going to make a little note that this red image is our original, okay? We need to find the scale factor between the two different examples, okay, and determine if they are similar or not. Since we have two different images, okay, I'm going to draw a line down the middle so that we can focus on one at a time. So we were asked to determine if they were similar, and in order to do that, we have to find a scale factor. So first, in order to determine similarity, remember, similar polygons have congruent angles, okay? First and foremost, always check your angles first. We know that rectangles have 90-degree angles in each corner. This goes for all rectangles, okay? So, since all of our angles are 90 degrees, or right angles, they are all congruent, okay? Next, the big thing is our scale factor. Okay, we need to see how much we are changing from our original image to our new image, okay, in this case, the blue. So to do the scale factor, you have to check every single corresponding side. Okay, it has to be the same factor, the same ratio for each corresponding side. So for our first one, we're going to take side BC, and we're going to look at the side it corresponds with, or in this case, FG. Okay, so I know that BC is a length of 8, and FG is 12. Okay, this gives me a scale factor of 2/3 from BC to FG. Okay, so it gets bigger by 2/3. All right, next we're going to look at the other pair of sides. So we have DC here, which is 10. And then for GH, or HG, we have a length of 14. Okay? When we go to reduce this, we can factor out a 2. So divide both by 2. And that gives us a scale factor, or a ratio, of 5/7. So we need to look at these two ratios and say, are they the same? Because remember, in order to have a similar image or a similar polygon, each corresponding side has to have the same proportion, okay? Since these are not the same, they are not going to be similar, okay? So ABCD and EFGH are not similar, all right? So these are done. Now we need to move on and go from red to green. So we follow the same steps. First, check your angles. Do we have congruent angles? Yes, because all are right angles. Okay, so we want to move forward and check our scale factors between the two images again. So just like we did before, we're going to look at our corresponding sides. So we have BC, which earlier we know was 8. Now we're looking at the corresponding side KL, okay? So this would be 12. How do I know it's a corresponding side? How do I know it's not JM? Well, look at your image. BC is the back end of the dog. KL is the back end of the dog. So these would be the same corresponding sides, okay? So BC is 8. Ooh. Here we go. KL would be 12. So like we did before, reduce your ratio if you can. We get 2/3. Cool. That was the same scale factor from before. Let's check our last sides. All right. So we're going to go to side CD, which is, again, 10. And then look at our last side, LM, which is 15. So in this case, we can factor out of 5. So divide both sides, or both numbers by 5, and we get 2/3. So we have both given side lengths, 8 and 10, 12 and 15. Now we have the scale factors for each on each image. Do these two match? Are they the same? Yes. Okay. So since both of our corresponding sides are proportional and have the same scale factor, we can say that, oops, it's not a triangle, it's a rectangle. ABCD is in fact similar to JKLM. Awesome. So, one more thing before we finish up for the day. In relation to the perimeters of similar polygons. So far we've learned that similar polygons have congruent angles, and we also know that their sides are proportional, okay? We know the scale factor is the difference between the two images, okay? So let's see what happens when we put all of those together. If we're looking for the perimeter of a similar polygon, we know that when two polygons are similar, their perimeters are proportional to the scale factor, okay? So the perimeters will match the scale factors of the polygons, okay? Or they'll be proportional, okay? So what that means, if we have ABCD is similar to JKLM, then the perimeter around ABCD over the perimeter of JKLM will be congruent to the proportion, the scale factor between the images themselves. All right, so let's look at an example of that. We're told that ABCDE, this pentagon here, is similar to PQRST. We want to find the scale factor of ABCDE, so starting here to PQRST. Then we need to find the perimeter of each polygon, so both polygons. So there's 3 steps that we need to do. Let's go in order. So first step, scale factor. All right, we know that the scale factor is a ratio of the corresponding sides. Okay, so let's look at our corresponding sides. We have a bunch of numbers up here, but down here we only have RS that is given. So which side does RS correspond to? Okay, I know that RS corresponds directly to CD per my similarity statement. So I can say that RS, oops, no, we want to go in order. So RS corresponds to CD, but look at the order that we need to go in. ABCDE to PQRST. So start with CD first, CD, and then RS. Plug in those numbers, 4/3, and then here we have our scale factor, okay? Key thing with scale factor, go in the order it's asking. So this image to this image. RS goes on bottom, right? Next, we need to find the perimeter of each polygon. So I want to say I'm going to find the perimeter of ABCDE first because I have a lot more data to work with, okay? So in order to find my perimeter, I need to know the length of each side. Here I have 2 congruency marks, so these are both 8. And then here we have 2 congruency marks as well, so these are both 4. Okay, so to find my perimeter of ABCDE, we're going to add up all of our side lengths. So 8 plus 8, 4, 6, and 4 more. Okay, that's going to give me a total of 8 and 8 is 16, 20 plus 10 more would be 30. Okay, so my perimeter of ABCDE right here is 30. That is done. Last step, we need to find the perimeter of our other image, our other polygon or pentagon, okay? In order to do that, we just learned that the perimeter of a polygon is going to be proportional to the scale factor, okay? So remember, we just read that. Perimeters are proportional to the scale factor. All right, remember proportions, you have to set something equal to another. 2 ratios equal. So let's see what the perimeter is. All right, we know the perimeter of PQRST, okay, has to be proportional to the perimeter of ABCDE, okay, by our scale factor. So let's start with our scale factor. So 4/3 is how it changes between the images. That is equal to or proportional to the perimeters. Okay, so we have the perimeter of ABCDE up top, because remember, our scale factor, we started with CD. 30 relates to ABCDE, so these have to be in the same position. And then we want to find the perimeter of PQRST, X, which is what's missing. Okay, so ABCDE perimeter. This is the scale factor for ABCDE. PQRST, just making a few little notes in case you were wondering what these are. Okay, so we have our scale factor, our perimeter of ABCDE, and then this X is the perimeter of PQRST. All right, so now we just need to solve our proportion. Okay, so in order to do that, we're going to cross multiply. Okay, so we get 4x equals 90, because 3 times 30 is 90. Right? Then we just divide by 4, and we get x equals 22.5. So we know that our perimeter of PQRST is 22.5, which, if you were to plug that back into our proportion, 30 over 22.5 would be, in fact, equal to 4/3. Let me know if you guys have any questions. Great work today, guys. Bye.